Okay, can we are you all ready? Okay, we are on page 7. Now, what we are going to talk about now is the application of KSP. Okay, so there are a few different things that it will be useful for you to know about because they have practical applications. Now, I want you to think about a situation here which you may not be aware, but nonetheless, it actually is of a real-world application. Okay? Here, you have a situation where you have silver ions and lead ions. Okay? Some of you are very obviously not ready for my lecture. A lot of you will not do well in the jungle simply because you move too much, and movement attracts attention. Generally, I will tell you something about myself. The quieter I become, the more dangerous it is for you. Now, I'm not particularly pleased with the beginning of this lecture. I think that you do not have a good grasp on reality. Your teachers are trying very hard to make sure that you clear your promo exam. Judging from my observations, I don't rate our chances of success as very high. Simply because, partly, there are things within your control that you are not doing anything about. Number one, your attitude. You simply are unable to focus when required to. The thing that I know that you don't is what's coming. And when I tell you that everything that you have studied after the mid-year exams is important, I speak from knowledge and not speculation. When I say that most of you do not have a sufficient understanding of the material, I speak from observation. Are we ready to begin? Okay. We have a situation here where there is silver ions and lead ions, okay, they have different solubilities. Okay, the chlorides have different solubilities. So when you put a chloride in, the less soluble salt will precipitate out first. In this case, it's silver chloride. If you follow with more chloride, okay, eventually when the concentration gets high enough, the lead chloride will precipitate out. Now, if you stop adding chloride at the second stage, okay, you will actually be able to separate out the silver from the lead, which is of use industrially. Okay, and what you will be learning to do is how do you calculate the point at which you stop, because this is a quantitative thing. Okay, it's not based on observation of, okay, the other precipitate, the color is precipitating, yellow lead chloride is precipitating out. No, this one you can actually calculate because you know the KSP values. Okay, so less soluble salt precipitates first. In this case, if I just simply give you the KSP, it's of little direct use because they have different ions, different number of ions. Okay, so you can't just use the KSP directly. So what you need to do is to calculate the chloride equilibrium, okay, for each to be precipitated out. So for silver, that is the equilibrium. Okay, that is the KSP. You should be able to solve for X, and AgCl will precipitate when the chloride concentration exceeds that of 1.6 10 times the power of minus 6 mole per dm cube. Okay? For lead, you do a similar thing. There are two things I want you to note here. Lead produces 2 chloride ions, so make sure you know, you write that down. And because of that, the KSP value, the concentration of chloride should be squared. Okay? So you should be able to solve that. That is 0.1 mole per dm cube. Okay? So you will see that there is a 10 to the power of 5 difference in the concentration of chloride. Alright, so with such a difference in solubility, you will be able to separate out the silver ions and silver chloride from the lead ions. Okay? Okay, next thing. We are going to talk about 3 different cases from your QA. Okay? I will refresh your memory since I think for a significant proportion of you, you would be unable to describe the observations that I would like. You test for chloride using silver nitrate. Okay? Then, so you should get a white precipitate. That white precipitate should dissolve in aqueous ammonia. Now, what you need to realize now is that when a precipitation occurs, it is likely that a reaction has occurred. When that precipitate subsequently dissolves, when you add another reagent or another solution, it means a second reaction has occurred. Okay, and then you need to be able to figure that what that is. Okay, so So KSP of silver chloride is actually very low, okay, 10 to the power of minus 10. So a very small amount of it dissolves. So chances are, whenever you have chloride, you have even one drop of silver nitrate solution, okay, you will get the ionic product exceeding that of the KSP. Okay, let's go through what this means again. The ionic product is the concentrations of the silver ion and the chloride ion at that particular stage. Okay? The KSP represents the maximum amount of silver ions and chloride ions that can be soluble in the solution under those conditions. Okay? Now, that value in this case is so low that even adding a bit of silver ions to a chloride solution will cause precipitation, which you will all observe in the lab when you do this test. Okay? So, some of the silver chloride actually dissolves. Most will not dissolve. Now, so there is an equilibrium, AgCl to give you Ag plus plus Cl minus. Okay? Now, when you add aqueous ammonia to this equilibrium, okay, what happens? Your observation is that the white precipitate dissolves. So, it doesn't just happen. There must be a reason. Okay, so the reaction that happens is actually this. The silver ion will react with ammonia to form what we call a complex ion. It is an ion with silver and there will be ammonia dative bonded to it. Okay, two of them. Do you need to know this equation? The safe answer is yes. Okay, so this is soluble, this is colorless, and the name is diamine silver complex. The name is less important than the formula. So if you are unable to remember the name, but you can write the formula down, it's fine. Okay. All right. Okay, so let's look at the next slide. Now, what's actually happening is, okay, I want you all to get this thing straight. The silver chloride and the ammonia don't react directly. What is happening is a shifting of two equilibriums, or two reactions. One equilibrium and a reaction. Okay, so when you have silver for Ag plus and Cl minus, okay, the IP is that when you form the complex, the concentration of the silver ion changes. It actually decreases because the silver ion and the AgNH3 plus are different things. When I say silver ion, I just mean silver plus. AgNH3 plus is a different substance. Okay? So the silver ion will decrease, and therefore, when you put the numbers into to calculate the ionic product, you will find that it becomes less than the maximum, which is the KSP. Therefore, when that occurs, equilibrium 1, which is the dissolving of the silver chloride, will shift to the right. Because you're removing Ag plus, it will shift to the right to replenish some of the Ag plus. Okay? And then it will stop when it reaches, the ionic product reaches a maximum value, which is the KSP value. Okay? So some silver chloride dissolves. Now, if you add more ammonia again, then this process occurs again until all of the silver chloride dissolves. Okay? Okay, so we need to know for chloride, bromide, iodide, okay, the situation. One way to tell them apart is by the color. There's white, okay, for the chloride. Bromide is intermediate between the iodide and the chloride, so it's cream. Iodide is yellow, okay. Chloride will dissolve in dilute ammonia and concentrated ammonia. Bromide is partially soluble in dilute ammonia, but it will be soluble in concentrated ammonia. Okay, iodide is insoluble in both dilute and concentrated ammonia. Okay, the other thing is when you expose to sunlight, the black and white film, right? You get it. What is actually present in the film is silver. There are silver salts at first when it's exposed, and then once it's exposed, there will be silver deposited. Okay, and why you get a nice picture is that the particles are small enough. It's like on your computer screen, you know the definition of it. So if you get very good film, it's actually small enough for you to form a picture. Okay, so the question now becomes, why doesn't the silver iodide respond in the same way as the chloride and bromide? Okay, so let's look at this equation in general. Now, adding excess ammonia, let's say, okay, if you form the complex, you reduce or decrease the Ag plus concentration, okay, and therefore equilibrium 2 will shift to the right to compensate for the decreased silver ion concentration. Now, think about this. The problem is that the KSP values for all three salts are different. The KSP value for the silver chloride is actually much larger than that of the silver bromide, which is larger again than the silver iodide. The silver iodide is really, the KSP value is really small. So, it's so small such that even though you lower the silver ion concentration, the ionic product, the concentration of silver times the concentration of iodide, is still going to be greater than the maximum value, the KSP for silver iodide. Okay, so it's not that it doesn't form the complex, it's that the maximum value of the iodide that can dissolve is so small that you cannot decrease the concentration of the silver to such a low level that the silver iodide will dissolve. Got it? Okay, so it is going to be insoluble in both dilute and concentrated ammonia. Okay, for bromide, okay, it is intermediate to the situation where for silver chloride and silver bromide. So bromide, it will dissolve, it's hard to dissolve when you use dilute aqueous ammonia. However, when you use a more concentrated solution of ammonia such that more of the complex forms, more of the Ag NH3 2 plus forms, okay, it will be able to dissolve. Alright? Okay, so let's look next one. Okay, now let's talk about copper. Now, for copper, try to recall what you have done in year 3 or 4. You have copper sulfate solution, which is a blue solution. When you add aqueous ammonia, which is alkaline, you should get a pale blue precipitate that dissolves. That forms. If you continue adding aqueous ammonia to that pale blue precipitate, it will dissolve and you will form a dark blue or a deep blue solution. Can you remember that? Not showing you a video is deliberate. I'm trying to force you to remember. Because in the exam, you are not going to have any videos. Everything it has to be in your head. I think you all have gotten me angry enough today that I'm really speaking my mind. This is what I actually think. Everything has to be in here. When I say all these things to you, I can imagine it. Every single one of your chemistry teachers can do it. It's not a very big deal. Your Cambridge examiners cannot probably think of a situation where the student cannot visualize this. You can't even conceive of it. So if you cannot, you go and get yourself there. Either you go and watch a YouTube video and you remember it, or somehow you need to get there. Because that's what it's going to take for you to clear your chemistry exam. Okay, so why do you get that pale blue precipitate? Now, as you know from the earlier videos, from the earlier slides, ammonia, when you dissolve in water, will get you ammonium and OH minus. Copper 2 plus will get the OH minus to give you copper 2 hydroxide, which is pale blue. Okay? So, why does the precipitate dissolve to give you a deep blue solution? This thing here that complex ion that I'm showing is really what happens when you put dissolved metal, okay, or salt in water. Do you remember back to energetics? When we talk about hydration energy, we talk about the gaseous ion dissolving in water. So this is actually what happens. For the case of most metals, you will get them surrounded by, in a way we call it a hydration cage of 6 water molecules. Why 6? Is because probably the geometry fits nicely. Okay? So, CO2 plus doesn't just exist as CO2 plus alone. It is CO2 plus surrounded by 6 water molecules. When you add ammonia solution, okay, what happens is that some of the water molecules are replaced with ammonia molecules. Okay, the water molecules and the ammonia molecules, we will refer to them as ligands. When we teach, when you go to year 6, it will be covered in more detail under transition elements. Okay? So, this is a soluble deep blue complex. Okay? So that deep blue, dark blue color that you see is due to this. The blue that you see of copper sulfate is due to the CuH2O6 2+, that blue. If there is no water there, As in, let's say if I take copper sulfate solution, I heat it until it becomes dry, then there's actually no color. It actually becomes white. So this color that you see, it depends on what it's not a very smart thing to do when you know that I'm irritated and you are sitting in the first row. This is not a public cinema. If you're Golden Village, Jurong Point, you do whatever you want. Okay, when you form this, the concentration of the copper 2 plus decreases, okay, such that it becomes lower than the KSP and the position of equilibrium shifts left. Okay? Alright? Okay, so this will continue until everything is dissolved. Okay? Okay, next one. Now, this thing, you need to be slightly careful. Okay? It's not just due to the concentration of the chloride. The thing is, when you have saturated lead chloride solution, okay, you have that. If you simply put in dilute hydrochloric acid, it has the effect of shifting the equilibrium to the left, and therefore it's even less soluble because of the common ion effect. However, when you add concentrated HCl, another reaction occurs, which is the formation of PbCl4 2-. Okay, so Pb2 plus will decrease. The IP will be lower than KSP. Okay, so equilibrium 4 will shift to the right. Therefore, the PbCl2 dissolves. Okay? So, you have learned of 3 different situations. Okay? The silver chloride, the silver chloride, silver bromide, silver iodide, the copper 2 plus, and ammonia, and the lead. Now, why were these 3 explained to you specifically? Because this is part of your QA syllabus. You can be asked to explain this. So you must know these 3 situations. And? Okay. And you're almost there. You're almost at the end. Okay, so pH. Nelson, what is bone made up of? What substance? Which compound? Carbonate? What's it? Carbonate. Okay, I'm trying here to explain to you. I think the difference between how we see chemistry is that for me chemistry is very real. Okay, I see it in everyday life. And okay, so why did I act shocked when you say your bone is made out of calcium carbonate? Because calcium carbonate is soluble in acid. Okay, so if your bone dissolves very easily in acid, right? Or even in calcium carbonate is appreciably soluble in water. Your body is 70% water. Basically, I give you generously 1 year, that little baby will dissolve away, and you get a little balloon filled with water. That is to me what occurs. Okay, so just now I was talking to the students about how do you picture some of this. Okay, I once asked not in this school, in my previous school, whether cellulose is soluble. Then I told them that cellulose, most trees are made up of wood, right? It's actually cellulose. So my dear students there sounded, yes, cellulose is soluble. Cellulose is a polymer that is made up of glucose, sugar. So I look at them, then I say, really, cellulose is soluble. So the next time it rains, run outside, go and lick the tree. Go and lick the tree, you will get, you don't need to go to auntie to buy the sugar drink because the tree will be dissolving. Okay? Now, the thing about phosphate is this. It's obvious that your bones are made primarily out of calcium phosphate. Okay? It definitely has to be insoluble, because if it's not, you wouldn't be walking around today, since 70% of your body mass is water. Alright? Okay, now, it's actually very insoluble. Okay? So, however, when you put acid in there, okay, it's actually readily soluble. Okay, so now you know how to murder somebody and get rid of the evidence, right? Which is how my mind works also. I can put you in a bathtub of nitric acid. Your bone should dissolve. You need something else also which I'm not telling you. Alright. Now, what occurs is this. You heard of phosphoric acid, it's a strong acid. So when you have phosphate and then you have nitric acid present, what's going to happen is that the PO4 3- plus H+ will form hydrogen phosphate, which is HPO4 2-. The HPO4 2- plus another H+ will form dihydrogen phosphate. And then dihydrogen phosphate plus H+ will give you phosphoric acid. Okay? So there is a series of equilibriums. Now, one thing I want you to notice. Do you notice that this is a conjugate acid-base pair? Therefore, if for bio students in particular, you will come across this, because these three pairs make excellent buffers. Okay, I think the middle one in particular is especially useful because it matches the pH of blood. And if you go to the hospital and you look at someone, okay, I'm not very sympathetic. Sometimes I go to the hospital, instead of talking to the patient, I'll go and look at the medication. So the IV that's heading there, right, you will often see it labeled as PBS, phosphate buffered saline. It is phosphate buffer plus sodium chloride. To match is to give fluid to the patient, and it matches the pH and the concentration of the salt. Okay? So there is. Now, So if you go and put a lot of acid, basically, eventually, the phosphate will dissolve. Okay? Now, the interesting thing is this. Medically, we talk about kidney stones, right? The stones that form are affected by the pH of the urine. If the urine is very alkaline, what you get are calcium phosphate stones. If the urine is acidic, you will get other stones. For example, there can be uric acid stones. Calcium oxalate stones also are possible. Okay, but there are many possible kind of stones. Alright? Okay, so I'll just show you quickly this one. But this is, in Singapore, when it happens, you see, it's not very impressive because we don't have a lot of limestone. Okay? What happens is, in other countries, like if I remember Florida, whole houses can suddenly disappear into the ground. What's actually happening is this. There is calcium carbonate, okay, is quite soluble when there is acid. And the acid can actually come from rainfall, because when the CO2 dissolves in the rainwater, it forms carbonic acid. So given a few hundred years or 1,000 years, you can form holes in the hills. Incidentally, you know the case where the Thai boys were trapped in a cave? Those cave systems were probably formed by limestone areas and where there is rain coming through. Okay? Okay, so this is the equilibrium. Alright? Okay, now we have time to do tutorial. So take out your tutorial. I want to go through question 1 and 3. E, can you all see? Can move forward because I can't actually make it very much larger. If you can't see, please shift the seats in front. There's one very precious seat next to Tong Guang, so you can come and sit there. Okay? Now, question 1, part A and B are important because they tell you how to solve the basic questions of KSP. First one is, given solubility, calculate solubility product, which is quite straightforward. However, you need to know, there are basic things that you need to know, as in 1, what is the formula? 2, for example, the hydroxide, you need to multiply by 3. Because when they say solubility, they refer to 1 mole of the substance, not of the ion. So, the solubility of the concentration of the OH minus needs to be multiplied by 3. Second thing is, you need to go and cube the concentration of OH minus since there were 3 ions there. Okay? The question, they may ask you to write down the unit. So the unit should be mole per dm cube to the power of the number of ions present. In this case, it's to the power of 4. Alright? Now, part B, you are looking at, they give you the KSP, they ask you to solve, to find the solubility, which, okay, so again, two things to take note of. Solubility in what? So, first one, solubility in water. Means when you write the expression, it's straight away equilibrium. Don't need to consider whether other silver ions or bromide ions are present. This is pure water. There's all of the silver ions, all of the bromide ions will come from the silver bromide that is dissolved. Okay, you don't know the solubility, so you put the thing as S. Then, alright? Okay, so for S, are you done with part A? Okay, for part B, the thing to take note of is that you dissolve it in 0.1 mole per dm cube silver nitrate. So the initial silver concentration is not 0. Okay, so you need to take that into account for the equilibrium. Have you all copied B already? Now, here, when you write the expression, you see that for silver ion, the equilibrium concentration is 0.1 plus R. However, you can make the assumption that R will be small because this is a sparingly soluble salt. That means the salt is not very soluble. So, you can simplify the expression, okay, and then you get R is 7.73 times 10 to the power of minus 12, which indicates that your assumption is valid, because I think there is a 10 to the power of 10 difference in the concentration, and that is 10 billion. Okay? So you can make this assumption. Even if you want to go and solve your quadratic equation, I doubt that you will get any answer that is different to 3 significant figures. Okay? So, question 1 is important in that it teaches you to find the solubility product value given, okay, maybe you want to write this down now. for your next tutorial. Question 1A, you find KSP given solubility. Question 1B, you find solubility given KSP. Question 1B part 2 is common ion effect. Okay, so often the rest of it is simply harder applications of this. Okay? These hydrangeas, right? They are quite pretty plants. You can actually see them in the botanic gardens. And it's true that they will have different colors depending on the different soil pH. Alright? I think I better clear this up for your tutors before you all will start barking them. Well, lime doesn't mean go put lemon juice on it. Okay? Lime in the English sense is calcium oxide. So it means to put calcium oxide or calcium hydroxide on it to decrease the soil pH. Okay, let's do question 3. Peat is decomposing plant matter. It should be of interest to you because that is the stuff that is burning in Indonesian forest fires when they clear them for the oil palm plantations, and that causes the haze in Singapore. I should go and test the Tesla members. Especially those who don't come for meeting. No, Jia, we are not talking about your friend next to you. I know he comes. Okay, now, this one. You have, this is the other type of question that you will come across. You have calcium, they mix two salts, and they ask you to predict what a precipitate, whether precipitate will form. So, to do this, you need to calculate new concentration. You need to see, one, is there going to be a new amount? Does a reaction occur? Which sometimes does when there is acid-base reaction. Second, there will be, when you mix two things together, there will be a new volume. So check those two things, work out the new concentrations, new amount, new volume, and therefore new concentration. Then you need to see which one will precipitate. The obvious thing is because they give you the KSP, it should be a calcium phosphate. However, in my experience, it's not unknown that someone will go and work out the concentration of sodium chloride. In my good mood, I will just roll on the floor laughing, I told the other class. In my bad mood, I will drag you to the sea and throw you inside and ask you to show me where has the sodium chloride precipitated out. Okay? Cannot. Hey, people, honestly, this stuff about what is soluble, what is not soluble is year 3, year 4 work. Go and learn it. Because it's not the examiners want to be mean to you. They don't even realize that there are people who don't know that sodium chloride is soluble. Okay? So, work out the values. And in this case, you will find that the IP value is greater than the maximum that can dissolve, which is represented by KSP. So it will precipitate out. Have you all ever seen chalk before? Chalk as in stuff to write with. Okay, that's calcium sulfate. Okay, so 3B, I think I will stop here. Okay, so yeah.